Good morning, everybody, or good afternoon, depending on the time zone that you've joined us from. Thank you for joining us for a webinar today on GNSS denial at sea, risk, limits, and practical responses. I'm Liz Wilson. I'm going to disappear off quite shortly, but I did want to introduce our speakers today. We have Andy Proctor, who is the Managing Director of RethinkPNT. He's also the VP of the Royal Institute of Navigation and the Chair of the PNT Advisory Group, so obviously super well qualified to talk on this topic. And Oliver Potter, Ground Control's very own COO. He has been instrumental in delivering the solution that we are going to present to you in the second half of this webinar. So just super quickly, a couple of admin points. There is a chat function, a Q&A. The guys are absolutely prepared and ready to take your questions. They will be at the end of the session. So please feel free to use the Q&A panel to ask as many questions as you like. If we don't get to your question during the webinar, we will circle back later individually. And yes, the webinar is being recorded and we will circulate the recorded webinar to all the attendees and registered attendees after the event. So without further ado, I'm going to hand over to Andy to get us started.
Hello, everybody. Good afternoon, good morning, good evening, wherever you are. Myself here, I'm representing RethinkPNT, but I am also the Vice President of the Royal Institute of Navigation. So here today, I'm here as an independent, agnostic of any product or service. And I should also point out that I'm going to make a number of statements this morning in the first couple of slides about the impact of disruption to GNSS and PNT systems, the evidence for which can all be found in the Royal Institute of Navigation's Maritime Interference Report, published in January 2026, which I'm sure you can all find from your favourite search engine, but if not, my email address is at the end of the slide deck. Feel free to get in touch. Let me start really with a threat picture from the maritime perspective, as you see on the screen. The key point is that GNSS disruption is no longer an occasional anomaly or a niche technical issue. It's really now a daily hazard, operational hazard, in a growing number of maritime environments. And that impact is not confined to position fixing or time dissemination alone. We're not just dealing with signal loss, we're dealing with interference that affects workload, confidence, trust, safety, and the behaviour of multiple onboard systems at the same time. Many onboard systems are directly or indirectly affected. So we're talking AIS, ECDIS, radar, gyros, even man overboard systems and some engineering systems. So really, the problem becomes less of a bridge navigation issue. It's a full ship system problem. And when we consider the impact of interference versus spoofing, spoofing becomes much more dangerous because it's not simply the loss of signal. You can detect that fairly easily. The loss of signal is disruptive for sure. But spoofing creates a trust problem. Many systems will continue to function using false position or time. And then these false information packets can propagate into all sorts of systems, into communications, into safety systems, into logs, etc. And the evidence shows nowadays that this interference and this spoofing has really a large, moderate to large, I'll say, impact on crew workload. And from the report, some crews have also said that the problem has led them to operate in an unsafe or unlawful situations, which of course is very worrying. We have evidence to show that this interference and disruption affects many systems, cargo systems, ship systems, reporting systems. Actually, many of the things affected by the problem we're discussing here today are not primarily navigation systems. They're things that do other jobs in the maritime life. And that's why we say we really need to address this as a ship-wide system. We're seeing these interference and disruption events in choke points, ports, littoral waters, offshore operating. You can all have the experience and Google where these things are taking place. But really, where you've got heavy traffic density or constrained maneuver, what you're doing with a loss of trust is you're losing integrity, therefore you're impacting safety of life, which ends up being the problem for the mariner is that you've not just lost one source, but several sources of PNT or systems are confidently wrong at the same time, and that really does present a problem. This is evidenced in the RAN report by the connectivity plot, which is showing over 20 different types of systems across many categories of use that process GNSS positional time, which really has meant that it's silently become a dependency across the whole of the maritime environment, not just in the bridge. It does sound all very negative, the challenge here is that GNSS disruption can be detected, spoofing can be detected, but there is actually a deeper problem that's more systematic that sits behind these technical activities. Next slide, please, Ollie. Really what we're seeing here is system behavior. So the issue's not just that somebody's transmitting interference and causing those problems. The issue is what the contaminated position and time do inside integrated maritime systems, and what happens during the event, and more importantly, after recovery. Bad time on bad orbital data from spacecraft can persist way after interference and spoofing ends. And some of these effects only become visible much later, perhaps after the vessel has left the region where the problem occurs. And this is why apparent recovery is not necessarily the same as genuine recovery. And this does tend to lead to things like power cycling and complete lack of system trust and the use of multiple double and triple redundancies, increasing workload and increasing stress in probably what's an already very stressful situation. What we've also found is that guidance is inconsistent, actually. Training, while very good in some areas, is uneven. Quite a lot of learning about how to cope with these interference disruptions is on the job, and often much of it's not reported. So the operational challenge, this deeper behavior challenge, is not just the technical exposure, it's about organizational readiness. Do crews know what to do, whether they're allowed to do something, whether the procedures reflect reality, and whether old assumptions about simple signal loss are still valid. In any event, crews may actually not know what's failed, not know what can be trusted, and this presents really operational problems. So moving through the slide, gaps in the training and reporting and bridge procedures. I argue, and the Royal Institute of Navigation also argues, that it's not about better equipment all the time. Better equipment is absolutely needed. But along with equipment, we should have clearer doctrine, clearer accountability, better preparation. The Ops Group report, which you may be familiar with from the aviation domain, the Ops Group report provided checklists and guidance for pilots who experience this stuff when they're en route. And that's the sort of preparation that perhaps doesn't exist in the maritime domain, and maybe we need to think about that. the engineer's answer is to often buy multi-constellation GNSS, multi-frequency, buy two of something. But the evidence really is now clear that GNSS itself, as a standalone system, even the advanced versions are not robust protection in an active interference and spoofing region. Technical issues can be addressed in many ways, but they don't often solve these hidden dependencies, this really deeper behavioral challenge. So the issue, I argue, is layered resilience. We need to have more robust receivers, anti-jam, anti-spoofing measures where possible, independent timing, alternate PNT systems, plus trained crews and operating procedures to ensure that behavior doesn't become a threat vector in the same way that the source of the interference is. So, this starts with connectivity plots, bridge training, warnings before you go into interference regions, better testing of SOLAS and safety systems under representative, and we really know what representative conditions are nowadays. Plus, we need to have maritime focused interference monitoring and mapping. So before I hand over, the one message I really like you to take away from this short discussion here is maritime GNSS is no longer just a navigation denial problem. It's vessel wide. It's an integrity problem that impacts workload, trust, safety, and operational decision making. We must include warnings, procedures, better training, as well as better equipment, a better understanding of the equipment that we're using and how it interfaces to the rest of the ship. So I've been pretty gloomy and pretty, fear and uncertainty. So with all that doom and gloom, perhaps, I want to try to make it a bit more uplifting now. And I'm going to hand over to my colleague, Ollie, from Ground Control, who will talk about some of the ways that the ground control solutions do address many of the aspects here that I've put down on the table. Thank you. Over to you, Ollie.
Thanks, Andy. Super interesting to hear your insights, learn about the research and all of the considerations there for obviously maritime operators. So I'm Ollie Potter, Ground Control, and the COO here, and delighted to take you through our view of the world. So very quickly, we're a business headquartered in the UK, but we're owned by CLS in France, and we have tens of thousands or hundreds of thousands of tracked assets. And to give you an illustration of that, we took all of the things we've tracked since 2020, so over the last 5.5 years, and plotted them onto here. So you can see us tracking things, obviously significant amount in the maritime space, but aeroplanes and trucks and trailers and things as well around the world. So we're significantly into tracking. Andy's obviously talked about lots of different solutions out there and talked about a multi-layered approach to this, and that's absolutely what we would recommend as well. There are things that I think will work really well in conjunction with what we offer, but there is no kind of panacea here. So at the top, we've got the sort of anti-jamming and anti-spoofing technologies, the sort of SERPers of the world. They listen, they have antennas all around in a disc shape, and they're looking for spoofed signals that are different to the other signals they're receiving, and or obviously sort of see signals on one side and it's jammed on the other side of the vessel potentially. Those, I think, and this is from experience from our customers telling us, those work sometimes, and I think they're quite effective sometimes, but there are occasions where those systems get confused by the more sophisticated jamming and spoofing that's out there. And we're hearing stories of rapid alternating between spoofing and jamming, confusing those sorts of systems, but equally sort of dynamic spoofing, where you take the position of the vessel and you slowly move the spoofing off it. Certainly what we've observed through our customers is quite significant spoofing, which feels pretty obvious, but I think those subtle spoofing events are really starting to happen as well. We've already talked about a differential GPS as an option. It doesn't really help. That's just really enhancing the position of GPS. It's the same sort of signals and the same sort of susceptibility to jamming. And then there are a series of terrestrial systems where they're using shore-based masts in order to help you navigate. And I think they're a viable solution where they exist. But clearly they don't exist all over the world. And we have an increasingly global problem to solve for ships that transverse across the world. So we think some of these things are a good idea in conjunction with what we have, but none of these things I think you can rely on their own. And what we have is a bulletproof solution, which I'll take you through. So to take you through our solution, I need to introduce you to Iridium PNT. So this is a fundamentally different positioning service versus GNSS. Now, this is from the Iridium satellites. The Iridium satellites, they have 66 in an orbit around the planet. They are much, much closer than the GNSS satellites that are out there. So they're 25 times closer to the planet. They also have beams that are focused on the planet, so they're kind of really higher powered. And what that translates is the received signal on the surface of the Earth is somewhere between 800 and 1,000 times stronger than your equivalent GNSS signal. And because those signals are much stronger, if you were looking to jam those signals, you would need significantly more power. And even at significant power, you wouldn't be able to jam in a very big area because of the power of these signals from the satellites. Practically around the world, we've not seen anyone actually being able to jam this. So while theoretically it would be doable, you would need a very significant amount of power to do it. And then you can't hide that. You can't move that. You'd have to have a significant power source to do it in a small area. It's also encrypted. So as part of it, it's an encrypted service. You do have to pay for this service. And because of that encryption, you can't spoof this. So you don't get the spoofing, and it's very, very difficult to jam. And therefore, it's a very compelling solution. So all over the world, it works everywhere. And I'll show you a whole load of screenshots that we've got from vessels we have in Straits of Hormuz, in Persian Gulf, in the Red Sea. And we've actually got in the Black Sea, in the Baltics, we've got them everywhere. But I'll show you some of those examples later on. The only thing with the PMT service is it's not as accurate as GNSS. It's using a Doppler shift. So as the satellites come over, they send lots of burst messages down, and then our device is then calculating your position. And because of the way it works, you do have a degree of inaccuracy, which is in the sort of order of magnitude of 25 to 50 meters. And obviously, as a passage over time, you can really have a really good understanding of where your vessel is. But at any point in time, there is a degree of uncertainty to that sort of order of magnitude. Now, in commercial maritime, when your vessels and ships are 100, 200 meters long, our customers that we've already got are finding they can use this information really, really usefully, despite that accuracy limitation. So what have we built? So we're delighted we have built the product called the RockFLEET Assured, and I'll take you through that now. Just by a bit of a history, we are one of Iridium's biggest innovative partners. So we design lots of different Iridium things, and Iridium approached us 2 years ago, really excited that they had this service, and they thought we'd be a great partner to build a product with it. Since then, we've worked with Ambre down the road here, a private maritime security company, and they've helped us define some of the specification of the device, so it really works in the commercial maritime space, and so we've brought this to market. So what is it? So there's two units effectively. There's the radome that goes on the top of the ship and needs a clear view of the sky, so above the bridge somewhere with a clear view of the sky. And then you have on the bridge display in order to display what's going on and provide you with warnings around spoofing and jamming. So it's purpose-built for spoofing and jamming. It incorporates the Iridium PNT technology. It also has a GNSS feed into it, so it's constantly monitoring what's happening on GNSS and comparing the two with PNT as well. It's very easy to deploy. There is that single above deck unit. It comes with a mounting bracket. It has a single cable that you push in and screw onto it, and then you run that down to the bridge. And at the bridge level, we have a little power hub that you supply to the ship's power, and you plug the 2 units in into the chart plotter, and off you go. It's small, it's discreet, and we've got thousands and thousands and thousands of these on fishing vessels across the world. So the kind of the capability we have, and we know and understand that marinized environment. One of the requirements we had working with those initial launch partners was we wanted it to work in a piracy scenario. So if we're worried about those instances where there's jamming and spoofing going on, we're also worried about recovery of the ship or supporting the crew in those environments. So if there is power loss, the cables are cut, or the power is lost on the ship, this unit will continue to work for probably a couple of weeks, depending on how we alter the frequency of transmission at that point in time. So really powerful. So if your vessels were to get into that worst case scenario, you still know where it is. And even if it's jammed and spoofed, you still know where it is. It will show the position on the chart plotter. I'll take you through that in a minute, but it will it'll feed a 1 Hertz feed. So every single second, it will show the GNSS and the APNT position of your vessel down to the bridge, so they know what's going on. It will also alert and trigger alarms on the bridge if it detects jamming or spoofing. So if the GNSS signal is lost, it will immediately alert. If the GNSS signal is spoofed, it will immediately alert. If there's spoof and the way it's and if there's time spoofing, it will immediately alert as well. It will also monitor the GNSS position versus the APNT position. And if the GNSS position drifts out because you've got dynamic spoofing going on, as soon as it goes beyond the confident position of APNT, it will alert the crew as well. So even in those most sophisticated jamming scenarios, this system will alert the crew, and they'll know that they're then can't trust their main GNSS source on the ship. It also has an inbuilt satellite connection, so it operates independently and can pass that information back on the position of your vessels over to your cloud platform. So that could be into your private maritime security partner or into your tracking and mapping application, and it can go to anywhere. And that's a really simple interface that we have to share your data. So just to bring it to life a little bit more, so on the image on the left, you will always have, and this is the sort of view of the chart plotter on the vessel, you will always have the position of the vessel, which will be the PNT position. Around it, we have a number of dots you can see around the vessel. That indicates the confidence in that position at any point in time. And I talked earlier about the sort of 25 to 50 meters. That's what it will show. And occasionally that gets worse, but it quite quickly improves. And that's due to the position of the satellite in the sky at that point in time. The GNSS position is also shown, and that's where the live comparison is. So if you see it getting spoofed, you'll see the GNSS position move off, and it will trigger an alarm, and it will alert on the bridge. We can create it to support NMEA 2000 and NMEA 183. What a number of our customers are doing is operating this as an independent system on the bridge, and then having a 183 feed that they can choose to use into other systems at a point in time when they've lost confidence in everything else. So we can work with you to look at that. On the right-hand side then, at a platform level, I mean, a lot of our heritage is in IoT and sharing data really simply across lots of different platforms. So this is super slick and really well designed. But we can make it very easy with a few clicks on our platform to share your data with your insurer or your mapping platform, or your private maritime security partner, or anywhere you want it to go. We also have cloud loop tracking, which is a very powerful platform that allows you to monitor your ships, understand the history of where they were, particularly maybe in the event of an insurance claim. You've got all of that data there. You can also set things like geofences on there to alter behaviours. So if you wanted a geofence and you didn't want it to transmit in Indian waters, for example, you could say, I'm entering Indian waters and I don't want the service to transmit in that environment. All very simple, very easy to configure and do on the platform. So let's take a look. So this one back in March, a vessel in the Red Sea. On the left-hand side, you can see the GNSS track from the vessel. On the right-hand side, the APNT. And you can see the spoofing that's gone on around the GNSS side. Obviously, quite significant spoofing, and the APNT track, absolutely what the vessel was doing. In the Persian Gulf, this was a series of vessels where on the spoofing is very significant, all to one single point at the top of the chart there. Had no idea and couldn't rely on the GNSS in this period of time. But on the right, you can see the APNT position can show where these vessels have been going backwards and forwards from. And then this is definitely not dynamic spoofing and making it very subtle. This is in the Straits of Hormuz. On the left-hand side, you can see all of the crazy patterns that GNSS have been picking up. And then the right, the transit around Hormuz that this vessel made. And obviously the pattern of waiting outside there in advance as well. So we have obviously loads of vessels in lots of environments, and we can see this working everywhere around the world. So it's a very powerful and now used solution in the world. To summarize then, this is purpose-built. This is what it's for. It will report to the bridge and it will report to your cloud platform, so you have both the history and also the live situational awareness into the bridge of the ship. It's very easy to deploy. All of our customers have installed this themselves, haven't needed any further support to do that. And we've designed it very deliberately to be easy to deploy, given the challenges of logistics around ships that are obviously moving all around the world all of the time. And it's discreet and robust. It's got batteries in it, so it will protect your vessels in those sort of scenarios where there's power loss and things like that. So very powerful solution. I'm going to then pause now for Q&A. So if you want to get in contact with Andy or myself afterwards, here are our email addresses. But if you've got any questions, Andy and I will go through those now. And on my side, I'll pull up the questions and see what we've got.
There is one, Ollie. The question is RockFLEET approved for use, IMO approved for use on commercial vessels over 3,000 gross ton?
So it's a great question. There is no IMO category yet for the Iridium APNT solution. So no, it's not. We're getting our 60945, so we'll have that. And we are also looking at whether we do a wheel mark as a GNSS receiver, but there is no category at the moment for an Iridium APNT. So our customers are typically installing this as an independent system, and then some of them are using the 183 feed if they're in a scenario where they're totally blind, they're then using it. But otherwise, we've been doing it as an independent system, as a navigational aid rather than the main system.
Thank you. There's no other questions. So one of the things that I think I would be remiss to point out is that with my Royal Institute of Navigation hat on for a moment, we do have
I see. Andy,
then,
sorry, I think we lost you for about 10 seconds. So
did you? Oh, right. Okay. That's pretty bad. Sorry about that. I was just saying about the Royal Institute of Navigation has a PNT group and a maritime navigation group. So if you're interested in listening in these topics, I would encourage you to join the RAN, be active in the various groups to really get under the skin of these areas. But we do have a couple of other questions, which mostly I think are for you, Ollie. So
let me go through them. So a question here: is the system supported via an operations room support network, or is it plug and play? We've not designed this to work with your ship's comm system as per the IMO point earlier. It has its own inbuilt satellite connection, so it works completely independently. All it needs is power. You can then choose to use the 183 NMEA 183 feed into something else if you wanted to, but it doesn't require any use of the ship's network or anything. It's completely independent. Another question on class approval, not something we've got to yet, no. We have started conversations with a few of those, but it's not something we've got to yet. Since GNSS and Iridium both operate in L-band, does jamming in L-band affect both equally? So I guess two parts to that question. Yes, the Iridium is in the L-band. The Iridium bit is on the edge of the L-band, whereas the GNSS signals are over here, so it's not often been the target. But critically, the received signal is 1,000 times stronger than the GNSS signal. So even if you are in a jamming scenario, and we have been in jamming scenarios, as you've seen in the images, the PNT signals are still getting through. So even if you're jamming exactly the right frequency, the PNT signals are so strong they're still being received. 66 satellites, time interval between position fixes. So we're getting, I don't actually know, but many bursts per second and deriving a position. But we then calculate that as a position that's fed in a 1 Hertz frequency. So every second we're sending that down to the bridge. In terms of what you transmit to your platforms in the cloud, that's configurable. A lot of our customers are choosing every 5 minutes. Ships don't move that fast. Some of them are choosing 15 minutes, some of them are choosing hourly. But they're just round figures. You can configure it to do whatever is appropriate for your use case. Does it distinguishing jamming versus spoofing versus equipment failure automatically or require manual interpretation? It absolutely does. It will alert. I don't have a video I can show you here, but I've actually got some videos on LinkedIn, but it will alert. It will say spoofing detected, and it will tell you where the spoofing is. It will tell you if it's time spoofing, which is different. And obviously, if there's jamming, it will be signal lost, and it will say signal lost on GNSS, and it will report exactly those scenarios. Equipment failure is an interesting question, and I don't know. We haven't had a failure, so I can't ask that one. I can ask our technology people what would happen if there was equipment failure, but I guess it would be what type of failure would be in that scenario. Can we get NMEA 183 for other navigation equipment? So essentially, can we get the NMEA 183 sentences for other navigation equipment? So it's not IMO certified, but some of our customers, yes, are taking the 183 feed. The sentences, if you go into docs.groundcontrol.com, you can see the sentences that the system can output. And yes, they can be interpreted by other systems. What we're seeing practically is customers are choosing to have that as a secondary or third feed, and then only using that and only switching to it in the event that they've lost all confidence in their main GNSS feed. Are there going to be any updates to mandated policies and/or insurance requirements that mean you have to have one of these systems for navigation at sea? Fascinating question. Mandated policies, I don't know. There was definitely a letter from the navigation committee or something in the Baltics saying that people really needed to think about APNT solutions, but that wasn't a mandated, that was an advisory. And we are working with DNK in Norway to support their customers to underpin their war risk insurance. So if you're a DNK member, this is one of their approved solutions. And that is for them to have confidence that they know where all of their vessels are, particularly as they're transiting war risk insurance zones. So yes, I think is the short answer to that.
Can I just a quick point there on that specific topic? The IALA and the International Institutes of Associations of Navigation and various other bodies from Japan and from Norway and from the UK are currently looking at how one can improve SOLAS regulations, how one can improve the resolution on the e-navigation resilient receivers to include things like APNT, terrestrial positioning systems, to bring on the standards and the authorizations to use these types of products in the environments in a certified and regulated environment. So there is active work going on.
Yeah, thanks, Andy. And that stuff's not quick, and obviously the technology and the risk landscape moves. So yes. Another question here: if our vessels are already running the standard RockFLEET, which is our straightforward GNSS tracker, is there an upgrade path to assured, or does it need a swap out across the fleet? Unfortunately, it does need a swap out. The intelligence that goes in the a radome that goes on the top of the ship, it's quite different. We're having to put a lot more compute power into there. So yes, unfortunately, it is a swap out, but it's a similar ground control experience, so it will work brilliantly. So does Iridium PNT provide global coverage? Yes, it does. So the 66 satellites are on polar orbits, and they're transmitting this everywhere. There was an initial launch phase a few months back where it was only the main maritime areas, but it's now everywhere. And there are a couple of questions in here that I don't quite understand, so I will follow up on email with you guys and answer those.
Okay, perfect. Thank you so much, gentlemen. Really appreciate it. Again, if we didn't get to your question, obviously you can see we had quite a few. Apologies, but we will come back to everybody individually. And yes, thank you again, Andy. Really, really appreciate your time. Fascinating take on this. Ollie, as ever, great job. Really appreciate that. We will circulate the recording after the event, and you've got Ollie and Andy's emails on screen if you want to address questions individually to the gentlemen. And I think with that, we can call it a day.
Thanks, Andy. Thanks, everyone.